consisting of n nodes. Your task is to determine for each node the sum of the distances from the node to all the other nodes. Okay, we are given n number of nodes. The nodes are numbered 1 to n, and n minus 1 edges हैं. We have a and b. There is an edge between a to b. The sum of the distances from the node to all the other nodes. Sum of the distances from the node to all the other nodes. Okay, so 1 2 1 3 3 4 3 5. Okay, let's see. So 1 2 1 3 3 4 1 3 3 4. Is it 1 3 3 4 3 5? So for every node the sum of the distances. So for node 1 from all the other nodes, what is the distance of this one from 2? It is 1. Distance from 3, it is 1. Distance from 4 is 2. Distance from 5 is 2. For 2, the distance from 1 is 1, from 3 is 2, from 4 is 3, from 5 is 3. For 3, 1 plus 1 plus 2, no. So 1 plus 1. So for this 1 plus 2. For this one, from 3 it is 1, from 5 it is 1, from 1 it is 2, it is 3. Same way here, 1 plus 2 plus 3. Is it what they are asking? 6. There is one more node, right? Is it what they are asking? I think, yeah. So for 3 it is 1 plus 1 plus 1 plus 1 plus 1 plus, from 2 it is 2, 5 it is 9. What is this distance? 1 plus 2 plus 2 plus 3. 1 plus 2 plus 2, that means 8. So answer should be 6 9 5 8 8. Is it so? 6 9 5 8 8. Okay, I think I got the question. How to solve this? What I can do is, let's say we have this tree. So if we fix the root, what will happen? Once we fix the root, can we solve this? What is the value of n? Because from every node I can run a DFS and calculate this value, right? What is the distance of this node from any other node? But what if I fix the root? So that I have to do the DFS only one time. Okay, I think this should be enough. Okay, maybe one more. So if we look at any node, so let's say this node, what is this node? so distance of this node from any other node. So can we, let's increase this value. Okay, so for this node it has a subtree, it will only have one tree, or it can have multiple trees. Okay, so this will have a subtree, right? Let's say this is connected to this one only, it will be better, and this one is also connected to this one only, this way. So I think it has all the childs. Can I get the value from all the child? If for this subtree I know, for this node, if I know the sum of all the sum of the distances of all the nodes in the which are in the child of this, either grandchild or direct child, right? So if I know this answer, can I say if for this node also that's all those sums will increment by 1, right? Let's say for this one it is 0, right? It is 0, but for this one it will increment by 1, this will increment by 1, this will increment by 1, right? So 3, if I know 3, then the 3 will be incremented by how much time? So every distance till now, this one, so whatever the distance it got from here, they all will increase by 1. That means this subtree size, that means this edge will will it increase by 1 or by the size of this tree? I think by the size of this tree, right? So because it has 3 here, that means if I move this edge, where did this 3 come from? It came from here, here, here. Now for this one, this edge, this was incremented by +1, this edge contributed by +1, this edge also contributed +1. That means whatever the value was here, that much will increase by this edge. So +3 it will increase, right? So whatever, so it has 0, so it has 2, it has 0, it has, so it will increment by 1 only or by 0. Okay, so that means root nodes will have 0. How to do this? I think I'm going in the right direction. So it will increment by, so this edge will increment by this. So due to this edge, this distance will increment by 1, this distance will also increment by 1, this distance will increment here. So let's say what is the value of this for its subtree. So 1, so for this node it is 2, for this node it is 2, for this node it is 1. So 2 plus 2 plus 1 due to this one, so 2, 2. So that means it will be 5 for this one, also, so total 6. Is it so? So 2 plus 2 4 plus 1 5 plus 1 6. How did it increase? So it was 1, so it was due to this one. So it has the subtree size, okay, 2, right? It had the subtree size of 2, it has the subtree size of 1, so it incremented its value by 1. Okay, got it. So it will increase by subtree size. So in this node asks for this child, so it will increment by 1 by the subtree size of this child, plus 1 2 plus 1 3. That means plus it already has one value, right? So it will have the size of, so 1 plus size of the children. Okay, so it will have 4. So every no so every distance will increment by 1. That means there were 4 values, they all incremented. So let's say they were x plus y plus z, they all incremented by 1. So plus 1 plus 1, how many times they incremented will be the number of nodes, right? So how many values I had previously, that is the number of times. Okay, so it had 4, so it will increment it by plus 4. It will increment this, due to this edge it will increment by 1 2 3 4 5. So it will increment by 5, it will increment by 1. So what did it has? So 4 plus 5 plus 1, that means 10. Is it? So no. So let's see. So it is 2. So it is, so this distance, so for this node this distance is 2. Let me write here, this distance is also 2, this distance is also 2. Let's suppose this was not here, so I had one more node, so this distance was 3. Now when I am calculating this and this distance is 1, right? So what will be its value for, due to this edge? It will be 2 plus 2, no plus 3, this is 3 plus 2 plus, for this node also it will be 2, for this node it will be 1. So due to first path it is 2, due to this it is 3, due to this last path it is 2, then 2 plus 1. So it will contribute how much? 5 4 9 1 10. How did I get this 10? Can I calculate first the depth of each node, then do a DFS on the depth, do a DP on depth, right? The depth of this is equal to sum of depth of all the values, depth of all the nodes, right? So this depth will, no, this will have only 3, right? So it cannot be the depth from the root, or the depth from the root minus this depth. This way we can, but can we do directly in one DFS call? One is calculate the depth, right, and do a DP on the depth. So DP of V will increment by the DP of U, where DP of U will be the depth sum, right? So what about, I think, yeah, so it has, so this value, but let's suppose I got this value for this subtree. How will you get this for the upper subtree? Is it out? Not able to solve it or what? So we are looking for this node. Okay, So it had this value, this value, this value, this value, this value, right? So first distance came from here, second distance came from here, third distance came from here, fourth distance came from here, fifth distance came from here. So for any node u, can we say, if I already know the answer for this, right? So can I say, so what is the answer for this, by the way? So for this one, it will be, yeah, it will be better if we write for child and then for calculate for parent. Yeah, so let's say okay, so for this node, let's calculate what's the distance of this node from this node. It is 1. How much this node will contribute? It will contribute 1. It will contribute 1. It will contribute 1. But for this node, this node's parent, these node will now contribute plus 1, right? Plus 1, plus 1, plus 1. So they all will get incremented by 1. Because this one will now increment by 1, so that means this one will become 2, this one will become 2, this one will become 2, this one will become 2. But for its parent again, these will contribute how much? So it will contribute, so for this it contributed 2, right? This one contributed 2, but for this one it was contributing earlier, it was contributing 2, right? Because this one 1 plus this, and this node was contributing 1, and for this node it was contributing 1. Now for this node it will contribute 2. It will start contributing 3. So essentially everything, so whatever the value was there, everything is increasing by the size of this subtree, right? Because those many times I'm doing plus 1, because for every node, how many nodes are there, that many times I'm increasing by 1. So okay, so that means dp of u can be written as, dp of u is getting incremented by how much? Size of v plus dp of v. Is it so? Yeah, I think yeah. So because let's write the dp value of this node. How much is this? So due to 1 plus 1 plus 1 plus 2, right? How much? It is 3 plus 2 is 5. So this one has dp value of 5. What is the dp value of this node? So it is 1 plus 1. So first leaf node is 2, second leaf node is 3, third leaf node is 2, then it is 2, then it is 1, which is 3 plus 2 means 3 plus 2 5, 7, 9, 10. 9, 10. Can we say it was 5 and it had the size of how much? 5. That's why it incremented by plus 5. So this was 5 and this was already 5 and the size was 5, so it became 10, right? Yeah, I think we can write this. Okay, I got the formula for dp of this, but how to calculate for parent? Okay, so if I already know the parent's value, so let's do it here. So if I already know the parent, so you have this parent, this u, and it has multiple childs, v1, v2, v3. There is grandparent. Okay, we calculated dp of u, which was this value. Okay, so dp of u is fine, but what about, so dp of u is giving me this sum, okay, in the subtree of u, what is the value that we want to find. But what about the upper part, because the upper node also can have this what, okay, let's see what else it can have. So parent will have only one parent, okay, fine, but parent can have many, that means you can have many siblings also, right? Yep. So let's say it is u. It is u1 u2. So what about this third sibling, u3? So now, so we need to find what is the contribution of these subtrees which are coming from the upper, from the parent's age. What is the contribution of these? Can we say the contribution is nothing but contribution is nothing but the contribution from this node, contribution from this node, contribution from this node, right? Contribution from this sibling plus this sibling plus this sibling, but they will increment by 2, right? They all will increment by 2, because this, and again this one also, and again this one also, and whatever the value I want to find for u, that is already present here. So if I say it was dp1, it was dp1, and the upper part is dp2, then we can say what is the dpu of 2, dp2 of u. Only what was the answer I'm getting from this part, this subtree, right? Upper subtree. Can we say that all the parents so how much, so these values, if I already know the dp2 of parent, how much that will increase? I think dp2 of u can be written as dp2 of parent is fine, right? dp2 of parent, but that was from here, from this dp2 of parent. But since one distance is one is getting added to all of these, how many nodes were there apart from the subtree size of parent? That means this can be written as parent plus d plus the total size is n minus size of parent, right? So size of parent plus what is the value I'm getting from u1, that means dp1 of u1, but they will increment by how much? This plus 2, all of them will increment by 2. How 2 into size, right? Plus 2 into size of u1. So this value will be for all u belonging to children of parent except u, right? I think this should work. Let me verify once. Let's see. So for u, I think dp1 of u is fine. Okay, what is the value coming from here? Here. So keep on adding for every child v1. So size of v1, whatever the size of v1, they suppose it had 5 nodes. So all those nodes, I don't know where they were, but these nodes distances are getting incremented by 1, right, for due to this edge. So that means size of v plus whatever the size of v1, whatever the dp1 of v1 was already there, they all becoming they all getting incremented by 1. Similarly, they all are getting incremented by 2, by 1, by 1. And if I want to find this one, so that means dp2 of u, dp2 of u can be written as in the parents term. So if I already know the dp2 of parent, that means what was the answer coming from outside of this edge for this edge, right? So dp2 of parent, dp2 of parent will be incremented because all these nodes will have length, will be incremented by +1, right? So if it had 100 nodes, right, I don't know which edge I took, I would have added already here, that is what dp of parent is storing, but they all will increase by 1, right? That means dp2 of u will be the size of this. What will be the size of this? So total size minus the parent subtree size, right? That means total size minus size of the parent, okay, plus I can say that these values will be incremented by 2. Everything will be incremented by 2. How much? This node is incremented by 2, this node incremented by 2, 2, 2, 2, 2, 2, 2. This will increment plus 2, plus 2, plus 2, plus 2. How many times plus 2? So this will be number of nodes, right? So they all will contribute here, okay. So I think it is fine. 2 times this plus whatever the value was already here due to this one, but and they are incremented by 2. So I think this will work. Let's write the code. This formula keep handy, and so task is meant for each node the sum of the distances from the node. So what is the n? And n minus 1 edge, okay. Let's define our adjacency list of next. It is maximum 2 into 10 raised to 5. 2, 1, 2, 3, 4, 5. We will read, okay, between A and B there is an edge. Is it what? Yeah, A and B, that means adjacency of A dot pushback B and adjacency of B dot pushback A, right? Okay, we have read n and all the edges into n. Let's find the size. Let's make the root, fix the root at 1. That means we can call the DFS at 1 with the parent is -1. And what else? I need to calculate the size of each node. Okay, let's write vector of integers, size of every node. Size of every node is +1, is 0. Size of every subtree is 0 initially, so we don't need to call this. What will the DFS calculate? Can we also calculate that value, that second value, first value, first dp1 directly? I think we can, right? So in this function only we can calculate dp of 1 because it depends on v, dp of v and size of v. Okay, so let's calculate both direct in one function only. So vector of int dp1 okay, so we can say size of this node is 1, and go to all the adjacencies of u. If v is equal to parent, then continue, otherwise we can call DFS on v with u as the parent, and can say dp1, or we can say size of, okay, size of v is already calculated. So dp1 of v, dp1 of u, can we say dp1 of u plus is equal to dp1 of v plus size of v, because size will be calculated, of size of v is already calculated, and dp1 is also calculated with this recursive call. What is the dp value of a child node, of a leaf node? It will be 0, right? Because there is no node in the subtree of this from where it can get the distance. So that means just above that we'll have size. So dp is 0 of the leaf and size will be 1. So it just layer 2 node will get 1 value. I think it will work. Okay, so let's write the dp2 calculation. How will I do that? So dp1 calculation is done. Let's write dfs2 on 1 minus 1. Okay, and u and parent. Okay, dp2. When I come at u, I already know the answer for parent. Okay, and I need to calculate this value for every sibling u1, u2, u3 except u, right? Except u, yeah. So go to all the, I already know the answer for this parent. But how will I remove them? Okay, I think we can apply this thing here also. For you, for parent I know, n minus size of parent. So when I calculate for v, what will I know? What will be the parent? Will be u. So for v1, for v1 it will be these nodes, right? U will be the parent and these nodes sum, then only v1 will be able to calculate itself. Because what if for 1 there won't be any parent? I think, yeah, it's better to write in terms of v1, v2, v3 only. So let's traverse over all the nodes over the adjacency of u only, right? And calculate this value size, 2 times size. So dp1 of v1 plus 2 times size of v1, because every value was getting incremented by 2, so other than v. So we can say if v is equal to parent or v is equal to u, then we can continue, right? otherwise your totals ll sum 1 is 0. We'll have to calculate two sums, right? One sum is this. Yeah, we can write dp2 of parent directly. Sum is dp2 of parent. Okay. I want to calculate dp2 of u in this call, right? And minus size of parent. And minus what will be the n here? Let's write n here. df is 2. U and parent. What is the sum? Sum is nothing but the how to write this one? Let's think. So what it wants to calculate, okay, let's not write the base case first, let's write this one. So I will have my DFS call for every child. So let's go over all the child. Adjacency of u, and if it is parent only, we'll continue. Otherwise my DFS call will go only if I know the answer for u, where v will be this and u will be the parent. Okay, so what is the answer? dp of u, dp2 of u. What is the dp2 of u here? Is nothing but yeah, I think I got this, how to write this. So can I say when I'm calculating for u, so when I'm calculating for v1, so u is my parent, right? So in this method only can we increment the dp1, whatever the size of v1 was there, that means dp1 of v1 will increment by so for v1, if we say, so for v1, when I will go for calculating v1's value, I will go for calculating v1's value. So other than the v1 nodes value, so dp, so it will be for all the nodes except v1, right? What's wrong with my resume? So for all sigma v for all the neighbors of u minus v1, right? So for v1, will it be the answer? So let's all the neighbors are v except parent and v1, right? can I say it will be dp1 of v, right? So this value for this v1, it will be v, so they will increment by 2, right? Plus 2 times size of v. Okay. This should be run for every other node, and plus after this whatever is the value of parent, right? dp2 of u, right? So for v1 it will be dp2 of u. That means u should already be calculated, and dp2 of u, and whatever that value was, it will be incremented by 1, right? Because outer it knows it will be incremented by 1. That means plus size, that means total size minus n minus size of u. So in one loop calculate this one, and everything will be added by this one. dp2 of u, is it the same thing but in terms of u only? Okay. I think let's see. So here dp2 of u, how to do this here? Let's calculate this sum first. Sum is 0 for every node except parent. So now I will go for view, this v's calculation. Then what will happen? This v's calculation, what will happen? I think so I would need this value, right? So let's calculate the sum and then keep on subtracting for every v, every current v I am calculating. This way will optimize to go. This way it will not go to n square. So for every node I can calculate dp of v1 plus 2 times size of v, dp1, that means sum plus is equal to dp1 of v plus size of v, right? After this we have total this value for every child of u you can calculate. So I will call for v, I will subtract this value so that it can be for every other nodes v minus v. Okay, but then I need to know the, in fact, what is this value? This is the value for so this will be for v1, and v1 will go, it will already have this answer. No, so when I go to v, I already know the answer for u, right? Since when I'm coming at 1, I already know the answer of parent out of parent, like dp2 of 1, which is 0. we came for 1, it is 0. So dp1 of parent is already known. Okay, parent should not come in this equation. So this is fine for all the siblings. So first increment. What about the second one? This one we calculated, which is this one, and every time I calculate, so it will, so that means dp2 of u it will be different for different children or same for different children. dp2 value, it will be same for every children, which is nothing but the subtotal size minus this size, that will give me this size, plus the dp2 of u. So right now I'm calculating for u, right? So for u, that means dp2 of parent is already known. So I can directly say n minus size of my parent, n minus size of my parent. So what will be the dp2 value of v1 when my DFS call goes there? It will be the dp2 value of u, dp2 value of u, right? Yeah. Plus the subtree total size minus the subtree size of u, size of parent. So n minus, so we can say dp2 of u is nothing but dp2 of u is nothing but dp2 of parent, what if parent is -1, plus the total size, that means n minus total size minus size of parent. dp2 of parent is this value coming from this edge, plus the total increment will be n minus size of parent, n minus size of parent. What if parent is -1? Then it will throw out of bound, like -1 invalid something. But when I call this one, dp1 I already know, but do I know dp2? No, dp2 I don't know for this v1, right? Because this is this one. dp2 of v1 do I know? No. When I call the DFS on v1, I need to know dp u. No, no, I think it is wrong. What is this sum? I think dp2, let's not write in the parents term, let's write in u's term only, right? So dp2 of u in terms of u only, not in the parents term. Okay, so then it will be easier. How to write this? So we can say that if I'm calling my DFS on v, this v1, and then I already know the answer for, so that means when I'm calling at 1, I already know the answer for dp2 answer for 1, which is 0, right? Because there is no child of, okay, so dp2 of 1 is 0, which is defined. So that means dp2 of parent I already know, dp2 of u1. Let's not write it here. We have calculated total sum, which is v sum, and because when I call it here, I assume v1's dp2 is already known. So we can say when I call here dp2 of what? dp2 of v1 plus the total size minus size of this minus size of v1, right? Similarly, when I call at u, so I already know the dp2 of u. Let's say I already know the dp2 of u, and I want to know the dp2 of v1, then only I can call or my DFS on v1, right? So in this step, when I'm calling at u, I'm calculating the answers for its child. So let's say for u, I'm calculating for the answer for dp2 of v1. Yeah, now it makes sense. Okay, for dp2 of v1, what it will be? It will be nothing but dp2 of u plus n minus size of dp2 of u, n minus size of u, right? So we can say that my sum, that means let's write it here, dp2 of v is nothing but dp2 of u, because I already know the answer for this, plus n minus size of u, right? Because those everything will increment by n minus size of u, plus these other children's, right? So other children's, so other children's sum, which is this sum, right? dp1 of v1 plus 2 times size of v1. I think we have already calculated, but let's subtract it. So that means it will be plus sum minus if v1, because in sum it also includes this value, so we can remove this value. Okay, what is this value? This value is size of v minus size of v minus dp1 of v, right? Yep, dp1 of v. Then we can call the DFS on this. I think it will work now. Let's see. These all will be LL. Size can be int. Let's see. For every value, I calculate the sum for the childs of u, which is dp1 of v, each one incremented by the size of v here. No, 2 times size of v, right? Which for this value it will be 2 plus 2 times, so it will be 2 times size of v. So it will also be decrease it by 2. Then in my answer, dp2 of v will be dp2 of u plus n minus size of u. dp2 of u, what is the parent's dp2 value, upper value, minus plus what's the size of this? Okay, it will be n minus size of u. Okay, that looks fine, plus other values, which is sum minus, remove this size, Okay, minus dp1 of size minus 2 times remove this value, right? So why 2 times? Because I added it 2 times. Okay, then remove it 2 times. Because what was its contribution in the sum? Its contribution was, for this value, was 2 times the size plus dp1. So if I'm calculating for this one, I need to subtract same value. Okay, it makes sense. dp2. So for every node now I know what is the value from here, what is the value from here. So I think answer is the sum of these two, right? Yeah. So let's go through all the nodes, and I can write C out dp1 of I plus dp2 of I. Okay, let's verify n for everything. I'm reading A pushback B pushback 1, dfs 1 on minus 1 parent, and this. So first one is calculating dp1 value. So dp1 of child is 0, of leaf is 0. Okay, and size is 1. Go to all the children and call on the children, and children's value I know, so I can update the parents value. So dp1 is known here. Okay. So dp1 of leaf node will be 0, right? Yeah, but on the second level nodes it will be leaf node's value plus the size of the leaf node, which is 1, so it will be 1. Okay, then we have dfs2, which calculate dp2 of u. That means when I'm at u, I want to calculate the dp2 of v. U is the parent, so go to all the siblings of v, and they all will increase the answer by 2 times size of v plus dp1 of v, right? So I got the sum. Then go to every node. If it is the same node, then subtract this value, minus dp1 minus 2 times this. Otherwise, what is the parent's contribution? It is dp2 of u plus n, because n minus size of u was this many times it will be incremented. What if the edge weight is also there? Then it won't be this one, right? Yeah, because it is 1, then only I can write it. Otherwise that will be a very complex problem. Okay, sum minus 2 times size of v minus dp1 of u, and then calculate the value of the child. I think by this, after this we will have dp1 dp2. What is dp2? Vector of dp2 of nax 0. What is nax? 2 raised to 10, 2 into 10 raised to 5. What is infinite? Okay, ll should work. Ll is what? Long. Okay, let's verify. Okay, we need to write it in the same line, not this. Okay. Compilation error. Nice. Okay, I think it is complaining this one. Size we cannot use. Okay, let's replace size. Okay, size. Can we also update the size of every node? Yeah, size of u will increment by size of v. Yeah, I think it was missing. Okay, size of u is 1, then size of u will increment by size of the child, size of its child. Okay, go here, update it, should it work now? No. Okay, no type. these errors. Void DFS. Okay, DFS 1 or DFS 2. Calling DFS 2, DFS 2, DFS 2, DFS. What is wrong with this? So function invalid type for array subscript. Finished. Unresolved overloaded function. How many DFSs are there? 26. Okay, it is this one. Okay, what's wrong with you now? Okay. Okay, let's read it once. Okay, scene N 1 to N AB, scene AB, push back DFS 2 and then go through N and write the values. Okay, looks fine. Vector of int adjacency, next LL is my value. Then int N UDP1 of U is 0, size of U it's maybe size is doing something. Size 1. Let's write SJ as size. Okay, so SJ size there should be shortcut also. Command SJ. No, it won't work. What the let's upload it and try. No compilation error, please. Okay, wrong answer. Okay, at least something. What could be wrong? Should it increase by one more thing? Okay, so leaf node is at 0, but the 1 is at 1, so everything will contribute 1, right? Sum of all the distances is 1. Now when it will go upside, so it will, whatever the value was, suppose 3, so 3 which plus 3, why? Because this one was incremented by 1, this was incremented by 1, this was incremented by 1, so it was incremented 3 times. So this 3 plus, so what the subtree size is 4. Subtree size is 4, so I must be getting less answer. Yeah, that may be due to this this should be the problem. Let's see. So for this leaf node, okay, so leaf node's answer is 0, okay, because there is no, but if I have a parent, so answer will be the size of this, which is 1. Sizes are inside, sizes are 1, so so I am doing dp of 1, dp1 of u, which is 0, it is getting incremented by the dp size of v. Size of v is already calculated, right? I already know, which is 0, which is 1 plus 1, which will be increment, so that means it will increment by 1, so 1 for this value plus the dp1 which is 0 plus the dp1 which is 0, so it will become 2. Similarly here also it will become 2. But what about this one, this parent? So for this parent, so the dp, the size, what is the size? Size is, okay, there is something wrong with the size I said. So size of v, u is nothing but 1, but size is already 1 for every node. Okay, size is already incremented by 1, so size, previous size was 1, so it will increase by 2 due to this node, so it will become 3, and due to this node it will become 5, is the size 5, so 3 3 6, so its size is 3 now. Why did I write 2? This size is 3, this size is 3, but the value, that means dp value is nothing but this size plus dp1, so it is 0 plus size which is 1, it is 0 plus size which is 1, so it will become 2. That means the distance of every, okay fine, it will be 2. Now for this one the size is, what is size? Size is already 1, So size is already 1, so it incremented by 3, it incremented by 3, so size becomes 7, and value will become what? So whatever the value was 2 plus the size which is 3, that means 5. Now it will also increase 5, that means value will become 10. Is it so? So 1 2 plus 2 plus 2 plus 2 4 plus 1 5 plus 1 4, that means 8 8 9 10. Yeah, dp1 is fine. Something wrong with this value. Will parent continue? Otherwise calculate the sum. V plus 2 times size of V plus 2 times size of V. dp1 of V plus 2 times size of V. Okay. dp2 of U plus n minus size of U is also fine, plus this will be constant for every, okay, plus the total sum minus, we need to remove this edge for, because we need to subtract this value or what? So I'm getting less answer, that means I'm subtracting more. So this has V1, this has V2, this has V3, this is my U. So I've calculated 2 times this, 2 times the size of this, so 2 times size plus dp1. So I'm calculating this value, so what all values I need? So 2 times size of this value plus 2 times size of this value, so that means for this value, for this V, I need to subtract this, right? So dp1 of V minus 2 times size of, then only for this value all the is incremented by 1, others are incremented by dp1 of V, dp1 of V, okay, dp1 of V is 2 times size of V, dp1 of V and 2 times size of V. Why it is not working? Every input is failing, only one is passing. Which one? Okay, it should pass. I'm close enough. 357333. Something wrong with my question, because values are going closer. 075811. Should I add something? So let's go through the test case. What were the values that we had put for this one? Let's try to find 1 2 so what was that? So 1 and 2 and 1 and 3, 3 and 4, 3 and 5. Okay, let's write the dp1 values. So value, so let's write the pair. Let's write this way: size, then dp1, then dp2. Okay, what is the size? 0? No, size is 1. Okay, size is 1, dp1 is 0. Size is 1, dp1 is 0. Size is 3, dp1 is, let's write this, dp1 is what? 1 plus dp1 is what? In the root, what's the distance so far? It is 2. For this, it is size is 1, dp is 0. For this, size is what? So 3 plus 1 plus 1, that means 3 4 5. Size is 5, dp1 is what? The size of what is dp1 value? The child's plus size of child incremented by the child's dp1 value is 0 plus size of child, that means it will increment by 1 plus the child's value, which is 2, plus size of child 3. 5 and 6. Is it 6 or so? So 1 2 plus 2 4, 1 5 plus 6 also, right, for this node. So let's see, 1 plus 2 3 hoga, 3 plus 2 5 and 5 plus 1 6. That means, okay, and what is the size? Is 5. Let's calculate dp2. dp2 means if I cut this node, what is the all the nodes? So that means first let's calculate for root. So for root is 0. It is 0, right? For root it is 0. So from root, let's go to this child 2. For root for this child, what will be the value if I cut this node? What will be the value? So 1 so 2, this child's value. So other child's sum, other child's which sum? So 2 times the size plus the dp1 value, right? This one, yeah. So dp1 value is 2 plus 2 times size. Size is 3, so that means 8. So this, how much it will contribute? It will contribute 8. Okay, is it so? So that means, so let's calculate. That means its contribution is 8. How? So for this node it is 3, for this node it is 3 6, and for this node it is 2, so 8. Okay, and what is the contribution of this? siblings plus the, what did I write? So this one is calculated, so dp2 which is 0 for plus n minus size of u, n minus size of u. So all this till now it is 8, so for this it is 9. So this distance is 1, this distance is 3, so 1 plus 3 is 4, 7 to 9, so it is 9. So 9 plus 0 is 9. So for 2 is it 9? Answer is 9. For 2 it is 9. Okay. But wait a minute, what is this formula calculating? I think n minus size of u. dp2 of u means, okay, they all will be incremented by 1. For this dp2 of 1 will remain 0, so for 1 it will call 2, it will call 2, 1 will call 2. For 2 the dp2 of 1 is 0, so dp2 of 1 is 0 plus n minus size of 1. What is size of 1? I think there is something wrong with the size, calculating the size. Size of this is 1 and size of u is increasing by size of v. It will call v, it means v size is calculated, and dp of u this formula looks right. Let's see. So from 1 when call comes to 2, 3, what it will say, find me, so it is 2 plus, it is 1, that means 3. Is it 3 for 3? 3 plus 2, 5. Is it 5 for 3? Is it 5 for 3? Yeah. So but what, how is this calculated? It is nothing but for its parent, that means go to 1 for 3. So when one call goes to this, when one calls 3, then this sum is what? That means dp of 3 is nothing but dp2 of 1 which is 0 plus n minus size of 1 which is 0 plus sum minus 2 times this value which is total sum minus 2 times size of 3 minus size of 1. That means for 2 it will calculate. I think this should work here. Why it is not working? Go to v, size of u, if v is parent continue, otherwise add this value. dp1 of v plus 2 times size of v. But if I have to calculate size only, so size is 1, then call this, then size of okay, with this size is calculated and with this dp is calculated. Then df is 2 on parent. dp1 of v plus size of v, sum is equal to 0, v over adjacency of u if v is parent continuous sum plus dp1 of v plus 2 times size of v. Okay, otherwise it will be v with the parent is u. What if there are parallel edges? Maybe these test cases, but all test cases cannot have parallel edge. Right. What's wrong with this? Why it is? Okay, does it have parallel edge 1 to 10, 5, 8, 3, 7, 8, 7, 2, 4, 6, 9? What are my answer and what is its answer? Thirty-seven, 30, 30, 37, 21, 6. Will it be dp1 plus dp2 or something else? dp2 is due to the parents. At least one should match, right? Because 1 is my parent, so for 1 it should match 21, 21, 27, but for other values it is not matching. That's the problem. It is it always smaller or greater? It can be both smaller or greater also. What is 333? Okay, it is always smaller. I'm missing something. I'm subtracting something more. Is it this one? Let's see. Is there something wrong with my formula? Okay, so u for calculating u. Go to all the siblings, calculate this value plus 2 times size of v, and go to this continue dp2 of v of u plus n minus size of u plus sum minus size of v minus dp1 of it will be 2 only. There are three nodes, so everything has 0 size, everything has size 1, so its value will be 3. 1 plus 1 plus 1. Now what it will give is size of 4. Means these nodes have contributed 2 and it has contributed 1. That means its value will be size of this plus the value of this, which these plus the value of this, which is 1 is this, and these values have incremented by 1, so 1 is the size of this is 4, so size of 4 plus, it means 4 plus by 4 y 1 1 1 plus 1 plus whatever the value was, this 3. Wait a minute, so this node, this node, this node, so 3 nodes, and one is this, one is this, so it will give me 1 2 3, size is 4 and dp value is 3, so for this value it will give 7. Why? So 2 2 2 plus 1 7. I think this formula is correct. dp2 has some problem. Okay, adjacency of u if v is parent continue, otherwise for all the siblings of v, how much they will contribute if I go via u. Everything, so do they increase by 2 or what? So there are 5 nodes, so every node's distance is incremented by 2, right? Every node's distance is incremented by 2. Okay, let's do this exercise, maybe we'll get something. So this node, this node, this node, this node, I'm saying it has size and dp1, right? So I'm saying dp1 means okay, everything here, whatever the value was. So what is the value here? the value will be size plus dp, right? Why size? Because suppose there were this many nodes, so their distances were, all these nodes distances incremented by 1, this nodes distance incremented by 1, this nodes incremented by 1. The sum will, so this node, this node, this node, from here it incremented by 1, it again incremented by 1, it again incremented by 1, incremented by 2. So for this out it will be incremented by 2. Simply whatever, so every nodes, so there will be suppose x nodes, and how many times increment? 2 times, right? But will it also do the same for this one? I don't think so. Yeah, got it. So all these nodes distances, so suppose the subtree size is x, that means there will be x minus 1 nodes, right? So these distances will increment by 2, plus this alone, this node which is alone will also contribute to the answer. dp2, let's say it has 3 nodes, so dp1 will be what, 3, and size is equal to 4. So for this, so it is incremented 1, 2, now 3 plus 3 plus 3, that means 9. How many times? 3. So if there was one more node here, then while calculating dp1, what will I add? So for this node I will add 1, for this I will add 1, for this let's write it here. So for this node I will write 1, for this node I will write 1, for this node I will write 1, for this node I will write 2, while calculating the values for this node. Now if I want to calculate the values for this node, so for this node, in context of this node, what value it will be? So it will increment by 2, right? So that means 2, that means it's incremented by 2. This node is also incremented by 2, this node is also incremented by 2, this node is also incremented, whatever the 2 was there, it is also incremented by 2, right? Okay. And what about this node? What about this node, right? It will also increment by 2. But what about this node? We never talked about this node, right? So I think that's where the value is less. What about this node? So I said okay, the siblings are incrementing 2 by dp1 plus size for v, but what about the parent? How much answer parent is contributing? So parent has one answer from here, right? Plus parent is also giving me this answer plus 1 also, isn't it? So these all what? These all are fine, they got incremented. So this sibling, so I have added in the sum, inside my sum everything is added. This value is also added, which is dp out, means dp2 minus subtree size of this. That means they all were incremented by 1. What about this node's distance? So for this node, this is also a node, right? I calculated the values per here, but what about this? So plus 1 I think I'm missing. Let's see. So dp2 will be 1 plus this. Let's try now. Everything is same. Okay, everything is same. Wow, it worked great. I think I was missing this one. Yeah, that's why answer was less. I got where this one is coming from. That parent I never saw. Nice question, by the way. Okay.